Hello everyone, I'm Vardhan Nukula, a member of Team Mavericks. This presentation gives you an overview of the project, which involves the integration of a vision-based robot manipulator utilizing ROS for assistive applications. So what is exactly our project about? Basically, it comprises of deploying a manipulator to do assistance-related tasks. It uses cameras and computer vision algorithms to understand its environment and decide how to interact with objects. We divided the work process into two phases. The first phase consisting of building the unmanned ground vehicle, configuring a Jetson Nano, operating the UGV using Mavros, and integrating a robotic arm to the UGV. A pre-existing six-wheel drive rover kit's base is used to build the UGV platform, and a self-designed aluminum molded structure is placed on the base and an external space is built for the battery. The UGV we are building is embedded with skid steering mechanism. The parts which we use in the UGV are Pixhawk. We use Pixhawk 2.4.8, which is an open source autopilot system. It works with sensors like GPS, IMU, encoders, and other environmental sensors to collect the information on the rover's position, orientation, and surroundings. Next, we have Sabertooth. We utilized a Sabertooth 2x12 motor controller which delivers a 12 amp output to the motors. It's used to regulate the speed and direction of the DC motors. GPS module with compass. We utilize the GPS module to determine the specific location, velocity, and the time of the UGV. And the last, we have a 3DR telemetry. The 3DR telemetry radio is a wireless communication link between a ground station and a UGV. It is transceiver module set that permits bidirectional connectivity for telemetry data and command transition. And lastly, we have the Jetson Nano. The Jetson Nano is an entry-level embedded computing platform developed by NVIDIA. Its GPU-accelerated computing allows efficient execution of computer vision algorithms and can also handle complex image processing tasks. We then set up the Jetson Nano by installing the Ubuntu 18.4.6 and downloading the Mav ROS in it. UGV using DroneKit to move it in a square shape, and we also use the GPS module to move the UGV from point A to point B in an external environment with the coordinates. For further development and controlling the robot system, we are using ROS, which is Robot Operating System. It is an open source framework for developing software for robots and robotic systems. It provides a collection of software libraries, tools, and connectivities that help us to create robot applications. It supports multiple programming languages, including C++ and Python. We then use Mavros, which is a middleware that provides communication between Mavlink-based autopilots, which is Pixhawk in our case, and ROS-based systems. Mavros provides a set of ROS packages that allow ROS nodes to communicate with Pixhawk using Mavlink protocol and also to send and receive commands and data to and from the autopilot. We then build the robotic arm using a pre-existing die kit and integrated it to the UGV. The robotic arm we built is a sixth direction of freedom arm which Phase 2 of the project consists of GPU-based object detection using Jetson Nano, development of vision system which we have planned to do using Raspberry Camera version 2, development of indoor navigation system using LiDAR mapping, and finally planned on designing a GUI using Qt and Python. Thank you all for being with me till the end of the presentation.